Hi friends, quick view of chapter 14. Let's start with transistor. Point contact transistor were invented in 1947. After that, junction transistor were invented in 1951, and after that, latest transistor. But in our syllabus, only junction transistor is mentioned, and junction transistor is also called BJT, bipolar junction transistor. Two types of junction transistor, NPN and PNP. NPN means N emitter, P base, and N collector, in which emitter is majority carrier supplier, moderate in size and heavily doped, and base is very thin and lightly doped, and collector collects majority portion of the majority carrier given by emitter, and it is large in size and moderately doped. We will see the use of transistor as amplifier, switch and oscillator, but before that we focus on structure and action of transistor. We have seen forward bias and reverse bias of transistor, and you have to be familiar with the three states of transistor, that active state, saturation state and cutoff state. When emitter and base is forward bias and base and collector is reverse bias, such state is called active state. In active state, what happens that emitter base junction has low resistance and emitter collector junction has high resistance, and you have to understand the role of VEB, VCB, VBB, IB, IC, etc. So to understand the basic action, emitter current and collector current are almost equal when transistor is in active state. Active state means emitter base junction is forward biased and base collector junction is reverse biased. So emitter current is equal to IH plus IE. What is IH? IH is Hall current. IE is electron current. So IE is equal to IH plus IE, and IB is very less than IH plus IE. Why? Because majority of electron will go to collector instead of coming out of base terminal. So what happens that we can neglect IB. So IE will be almost equal to IC. And voltage between emitter and base is denoted by VEB. Voltage between base and collector is denoted by VCB. So power supply between emitter and base is VBB. So this notation you should remember. And one more thing you have to remember, that in NPN current enters from base into emitter, and in PNP current enters from emitter to base. Now transistor can be configured in a different ways, but here we are restricted to only CE configuration, means common emitter configuration. In such configuration, input is between emitter and base and output is between emitter and collector. So when we want to study input characteristic, we have to study IB, and when we want to study output characteristic, we have to study IC. But IB with respect to VBE and IC with respect to VCE. So now let's see some important parameters of transistor: input resistance, output resistance and amplification factor of current. So our configuration is CE configuration, means common emitter. So when we are talking about input, always base will be included, and when we are talking about output, there will be collector. So RI, input resistance, is equal to rate of change of voltage between base and emitter divided by delta IB, means base current, when we are keeping voltage across collector and emitter constant. So just try to understand that we are talking about input resistance. So our formula is R is equal to V by I. We are applying this formula and we are applying Kirchhoff's law. So we will get Ri is equal to delta VBE divided by delta IB. And output resistance will be RO is equal to delta VCE, means voltage between collector and emitter, divided by delta IC when keeping IB constant. And current amplification factor beta AC is equal to delta IC by delta IB, means collector current and base current ratio is known as current amplification factor. And when we are taking IB 0, IC will also be 0. Therefore, at that time, beta IC will be equal to beta DC. Let's understand the working of transistor as a switch. Our circuit is in common emitters configuration. So whenever we are talking about input, a base will be included, and whenever we are talking about output, collector will be included. And all of you know that switch require on-off function. We are taking input voltage as a VBB. VBB is equal to VBE plus IBRB. VBE means voltage between base and emitter. And output will be equal to VCE. But we know that VCC is equal to VCE plus ICRC. So making VCE subject, we will get VCE is equal to VCC minus ICRC. So this will be our output voltage. And IC is equal to 0 when Vi less than 0.6. Then IC will be almost 0. So transistor will be in cutoff state. So do remember that we are taking input voltage and we get output voltage, and we are applying Kirchhoff's law, and we are applying the formula P is equal to IR. We observe that after 0.6 volt, if we increase Vi, VO will be decreased till its value become 1.0 volt. And after that, transistor is in saturation state. So how transistor working as switch, that Vi is low and VO is high, transistor is not conducting, so it is switched off or in cutoff state. And Vi is high and VO is low, transistor is switched on, it is in saturation state. So remember states of transistor, cutoff state and saturation state. You will easily understand the working of transistor as a switch. So to understand the study of transistor as an amplifier, we have to consider input signal and output signal. So when there is no signal, we know that VBB is equal to VBE. That is our equation number 1. But when signal is given to BE, and signal is always given to base and emitter, do remember. So our equation 1 will become VBB plus VI is equal to VBE plus delta VBE, because there will be change in input. Initially, no signal means VBB is equal to VBE, but signal is given, so input of signal will be added. So VBB plus VI is equal to VBE plus delta VBE. Delta is a change. So this is our equation number 2. But putting the value of VBB from 1, that VBB is equal to VBE, so our equation 2 becomes VBE plus VI is equal to VBE plus delta VBE. We can cancel VBE from both the sides, so we'll get VI is equal to delta VBE. But delta VBE is equal to Ri delta IB because of our formula V is equal to IR. So VI is equal to Ri delta IB, that is equation number 3. So now we will get input is equal to Vi is equal to Ri delta IB, and now we'll study output. And you know that to study output, you have to study IC, means collector current, with respect to collector voltage. So what happens that output voltage delta VCC is equal to delta VC plus delta ICRL. But there is no change in VCC, so delta VCC will be 0. And when we are talking about output voltage, we can take load resistance RL instead of RC. No change means you can take 0. So delta VCC is equal to 0. So what will happen? That delta VCE is equal to minus delta IC RL. That is equation number 4. Now you know that current amplification is beta IC is equal to delta IC by delta IB at VCE constant. So delta VCE will be equal to delta IBRL minus beta IC, and that will be our output. Why? Because we are taking the help of equation number 3, 4 and 5. And now we are going towards voltage gain. Voltage gain is equal to output voltage by input voltage. It is denoted by AV. AV is equal to minus beta AC by R into RL. And power gain is equal to voltage gain into current gain is equal to beta AC into AV is denoted by AP. And we get power gain because beta AC and AV both are greater than 1. So this is how transistor works as an amplifier. If you feed signal, it will get amplified, so intensity will be increased. Let's study about feedback amplifier and transistor as an oscillator. For amplification, we have to provide external signal to input. Means we have to feed external signal to input, and this process should be repeated to get continuous amplification. So what happens in oscillator? That a portion of the output power is returned back. Return back means feedback to the input with starting power, which is called positive feedback. And this process is done with the help of inductive coupling, means mutual induction, and LC or RC network. So now look at the description given in book and try to understand the working and function of amplifier as an oscillator, but it will be difficult for you to remember how exactly it works. So here I am going to give you a few steps and very useful for examination. So try to understand that steps and try to remember the function and working of amplifier as an oscillator. So let's understand this process step by step. Two coils T1 and T2 are wound on the same core for mutual inductors. And one more thing should be noted, that base emitter junction should be forward bias and base collector junction should be reverse bias for this procedure. So what happens? Suppose we apply switch S for the first time, then collector current increase and flow through T2 where terminals 3 and 4 are there, and this current reaches from X to Y. And we know that there is a coupling of T2 and T1. So due to this coupling, T1 gives rise to emitter current, and which is actually a feedback from input to output. And emitter current also increase from X dash to Y dash. When collector current reaches to value Y, what happens that a transistor will be in saturated state. So no current will flow through collector after that. So what happens? There will be no feedback from T2 to T1, and hence emitter current starts to fall. And so collector current also decrease from Y to Z. And collector current decrease from Y to Z, magnetic field around T2 also decays. And due to coupling, there is decay in T1. So emitter current starts decreasing and reaches to Y dash to Z dash. And transistor is in cutoff state. So this means that IC and IE both ceases to flow, and transistor is reverted back to its original state. So try to remember the action at X to Y, X dash to Y dash, and Y to Z, Y dash to Z dash. That's all. The whole process repeats itself, and time to change the state from cutoff to saturated state is determined by tank circuit or tuned circuit, and resonance frequency of that tuned circuit determines the frequency at which oscillator must oscillate. And the formula to find that frequency is nu is equal to 1 upon twice pi root LC. So highlight of today's video is to understand this chapter carefully. You have to understand the basic concept like biasing, input output characteristic of transistor and state of transistor, active, cutoff and saturation. So that's all for this video. Thank you for watching my video. If you like this, please share and subscribe my channel.